Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we've had a problem, but wait! No, we don't, because today we are going to understand LeChatliers principle. LeChatlier, the Frenchman from France. Henri LeChatlier. I'm not French and I probably butchered the accent, okay? So LeChatliers principle, which has to do with equilibrium, chemical equilibrium we learned about in the last video. And if you recall in the last video, we had a little metaphor, which is boy plus girl makes a couple. It's a reversible reaction. Remember, equilibrium is when the rate of the forward reaction equals the rate of the reverse reaction. Boys and girls get together to make couples. Couples break up to make boys and girls. Now, I know I'm being very... But Henri LeChatlier, he said something very interesting about systems at equilibrium. He said this. He said when a stress is placed on a system at equilibrium, the system will shift to relieve that stress. Now, it's not terribly difficult to comprehend this with our metaphor. So let's say, for the example that, and this is very contrived, let's say we go to the neighboring high school, the all-boys high school, it could be all-girls high school, and we bring in 150 more boys. Now, what's going to happen, ladies? That's right. You're going to have more choices. And the reaction is going to shift to the right because you're going to have more choices and more couples are going to get made. We're stressing it. So in the chemical world, when we add more chemicals, it shifts to relieve that stress. Or another silly metaphor, let's say we go to another high school and all we do is we bring couples back. Lots and lots of couples, and they start attending our school. And then what happens is, well, couples do what couples do and they break up. And the reaction shifts to relieve that stress. And you start making more single boys or single girls. And there's a weird one. And this metaphor isn't going to be perfect. If we could find something where we could take something away, and in the chemical world, the way to take something away is to find something that they're more attracted to. So let's say that boys just love chocolate chip cookies, and we bring in lots and lots and lots and lots of chocolate chip cookies. The boys and the chocolate chip cookies make them leave the school, and if they leave the school, you take away the boys, that will also shift it back to the left. Metaphor's not perfect, I guess. In the chemical world, we could take something like acetic acid, that's simple household vinegar, breaks apart into hydrogens and acetates. A reversible reaction. If I bring in more hydrogens by, say, adding some hydrochloric acid, that would shift the reaction back to the left. But I can also take something away, and the classic way to add something that the hydrogen loves, if you recall from acid-base unit, hydrogens love hydroxide because that turns into water. So if I were to add hydroxides, that would create less boys, if you will, metaphorically, and because they're going to leave and make water. So basically, they'd rather be attached to water than acetic acid. Like maybe it's a prettier girl or whatever it is. And it's going to drive this reaction back to the right, and you'll have a lot more acetate. So you can shift the reaction back and forth and back. Now that's how you change concentration, but there's other stressors you can put on a system. You can add energy. Okay, let's go back to our metaphor. I'm going to make an argument that it requires energy. You know, as a married man for over 25 years, if you want to take a boy plus a girl, me and my wife, for us to keep ourselves as a couple, this requires constant energy. We have to always be putting energy into our relationship so we can keep this over here on the right. And you know this when you got to call up or text your girlfriend or your boyfriend to make this actually happen, there takes energy. And when things break up, you know this, right? There's fights and somebody says bad things they probably don't want to. It breaks apart, it releases energy. So in the chemical world, let's say that this reaction, and I'm not sure which one this is, energy can be on either side of the reaction. Sometimes it's on the left, sometimes it's on the right. But if there's energy here, if I were to increase the temperature, if it's on this side, that would drive this reaction to the right. Conversely, if I cooled it, it would shift to the other direction. But energy on the other side, it would be the reverse. Let's watch a video clip of a cool experiment about how the temperature is affected by equilibrium. The LeChatliers principle can also be affected by temperature. So here I have 3 identical solutions of copper chloride. Notice the blue color, but we can affect it by temperature. So I've got both some ice water and I've also got some boiling water. I'll just take that off of the container. And I'm going to stick 2 of these, one into the ice water and one into the boiling water. So now if we compare the hot water one to the hot water on this side and the cold water, you can see it's a deeper royal blue. So we've got a bluer color in the hot water. And now let's compare the ice cold water one. Do you see how you're starting to see a hint of pink at the bottom? This is the one here, is the ice water, and this right here is just... If you come down here to the equation, the pink side is this side, and then the blue side is this side. It looked mostly blue, but when I heated it up, right, heat, this is an endothermic reaction, so I added heat, the reaction shifted to the right, and it turned that deeper blue, this color right here, because we're shifting it to the right. But when I took away heat, right, when I made it cooler, it shifts the reaction back to the left and made it this lighter pink color. And you can see the lighter pink color. So yes, LeChatliers principle is also affected by temperature. LeChatliers principle. When a stress is placed on a system in equilibrium, the system is shifted to relieve that stress. So Houston, we thought we had a problem, but we don't anymore. We'll see you in class.